Hi guys, my name is Ismail Dagani and I work in a shared lab with Blue Eagle Labs. Today we're going to calibrate the Costal Clear printer. We work in a shared lab called WorkLab CC, which is a great environment, and we're really excited to do this with you today. So the first thing you want to do is download the recommended software for the Costal Clear printer. You would do this by going to www.blueeaglelabs.com, and in the support link you want to click on Software Download. Inside there, you want to click on the link Costal Clear Recommended Software and save it anywhere. So the next thing you want to do is download the Arduino IDE software, and you can do this by going to www.arduino.cc. Click on their download link and download the IDE that is appropriate to your operating system. For example, if you have Windows, download the Windows installer, otherwise download Mac OS X. Go ahead and run the downloaded installer and you will start the process of installing Arduino. So once you've downloaded the KC software package, open it up, and inside there, go into the Marlin Bell folder. Marlin is the firmware that the Costal Clear printer uses. Inside Marlin, go to the subfolder called Marlin and find a file called marlin.ino. And if you've installed Arduino correctly, it should launch when you double-click this file. Next thing, go to Tools inside Arduino and choose the Arduino Mega 2560 board. This is the model of the board that the Costal Clear printer uses. Also choose the right serial port that goes with your currently connected Costal Clear printer. If you're not sure what this COM port is, you can go to your device manager, that's Start, right-click Computer, click Manage, go into the device manager, select the ports and expand it, and you should see Arduino Mega 2560 with a COM port next to it. That's the COM port that your Costal Clear printer is connected on. And make sure that corresponds to what's in your Tools menu here. Once you've set all that up, you just need to click the Upload button. That'll compile the Marlin firmware and send it to your Costal printer. So once you've installed the firmware onto your Costal Clear printer, the next thing you want to do is load up the Pronterface package. So this is inside the same RAR file that you downloaded, inside the Pronterface subfolder. Click on pronterface.exe, and that'll load the Pronterface interface. The first thing you want to do is make sure the COM port corresponds to the one that you know your Costal Clear printer is connected on. And you have to make sure that the baud rate is 250,000 bps. Once you've set these up, click Connect. That'll connect you to the Pronterface. That'll connect the Pronterface to the Costal Clear printer, and you should see a number of log messages appear in the status window. The first thing you want to do is issue an M119 command to the Costal. And this will give a status as to what the end stops are currently set to. So Xmax, Ymax are certain end stops, and they're open. What you want to do is test that they're working by holding down one of the end stops and issuing this command again. So now that I've held down the X end stop, you'll see that the Xmax is triggered. Similarly, when you hold down the Ymax or Zmax, you want to make sure that the Costal registers each one of them correctly. So now that we've tested all three of them, you know that your end stops are all working. So once you've verified that all the end stops work, the next step is to add a few custom buttons that will come in handy as you're continuing to calibrate your printer. So the way you would add a custom button into the Pronterface interface is clicking on this plus sign right here. And the button title for the first button that you're going to create is called simply X, and the command would be a G-code command that the pronterface will use to go to a specific location. So for the X button, it would be G0, F8000, X negative 77.94, Y negative 45, and Z0. It will become apparent why these buttons are useful as we're continuing to calibrate. So I'll simply paste that and click OK. And now you'll see that there is an X custom button in your pronterface interface right here. I'll repeat that for Y, Z, and the origin by following the same steps. Y. The Y button is G0, F8000, X 77.94, Y negative 45, and Z0. So the next button would be Z. You would copy G0, F8000, X0, Y90, Z0. And finally, you would make an origin button. And the G code for that would be G0, F8000, X0, Y0, Z0. So you should now have 4 new custom buttons, X, Y, Z, and origin, inside pronterface. So now that you've secured all the components in the printer, the next step is to home it. And you can do that by clicking this home button inside pronterface. You should see all of the 3 roller cages hit each of the end stops. So before actually calibrating, make sure that the bed is heated to the right material that you're using. This is because the bed expands slightly when heated, and so you want to make sure that your Z calibration is exactly in line with the heated bed. The way you would heat a bed is to change this bed setting depending on the material that you're using. So we're going to be using ABS in our test. I'll select ABS and I'll say set. You also want to monitor the printer, and this will give you a real-time view of what the current temperature of the bed is, and you need to wait until it reaches your target. So now let's start the general home calibration. The first thing you want to do is click this home button on pronterface. That will home the console printer. And then you want to issue a G code that sends the console nozzle very close to the bed. So I'll type it in right here. It would be G1 F4000, and that sets the feed rate, followed by a Z10. So this will place the console 10 millimeters above the bed. I'll issue this command by sending it by clicking the send button. So this is what the software perceives as 10 millimeters above the bed. Now in order to calibrate, the actual distance has to be accounted for. This is usually not exactly 10 millimeters. So that's what we're going to do right now with what's called a paper test. I'll grab a sheet of paper and place it right under the nozzle on the bed. And now I'm going to count as I actually get the nozzle closer and closer by 1 millimeter. I'll do that by clicking the Z minus direction on pronterface. First, I'll start in large increments of 1 millimeter. I'll click it once and keep counting as I'm clicking. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now you'll notice that the console software thinks that the nozzle is exactly at 0, but there's still some distance between the nozzle and the paper. So now is when you start counting in the negative. So -1, -2, -3. There's still some distance, and you can figure out when that distance becomes 0 by sliding this paper back and forth underneath the nozzle. And now I'll be going in 0.1 millimeter increments. So 1, 2, 3, 4, 5, 6, and now the paper has caught the bed, and it's very difficult to move it underneath the nozzle. So if you recall, I had actually moved it in 3 large increments and 6 small increments. So the actual distance that the Kossel had to travel was negative 3.6 millimeters underneath its previous 0. And now we need to put that negative 3.6 millimeters into Arduino, into the Marlin firmware. To do this, I'll open up the Marlin firmware and I will go into configuration.h. Inside there, you'll see so I'm going to go to configuration.h and find a variable called manual z home pos. That's manual underscore z underscore home underscore pos. And the default value would be 289. That represents how long the Kossel z direction has to travel in order for the nozzle to hit 0. So if you recall, the actual 0 is an extra 3.6 millimeters from this 289. So I'll open up a calculator. And what you want to do is add that 3.6 to your original value of 289. That gives you 292.6. And I'll go ahead and change that in the firmware. And now what I'll do is re-upload the new firmware with this new manual z-home position into the Kossel by clicking upload right here. If you receive an error message like this, COM6 already in use, be sure to disconnect Pronterface. This is because both these two softwares cannot simultaneously communicate with the Kossel. So I'll click disconnect and I'll retry the upload after Pronterface has disconnected. Okay, and now you see it done uploading, which means that the new Z position has been inputted into the Kossel printer. So once you've updated your manual Z home pos variable in Marlin into the Kossel printer, the next step is to just verify that these settings have taken hold. So what I'll do is I'll first go back to Pronterface. I'll connect again. And I'll issue a home command. This will send the roller cages back to their home position of Z0. The next thing you want to do is send a command in G-code to the Kossel printer. G1 F4000 Z0. This will bring the nozzle back to the 0 position so you can verify that your settings took effect. I'll grab the same sheet of paper again, place it on the bed, and send this command. The Kossel nozzle should stop right at the 0 position. And you can see it worked. Okay, let's start calibrating each arm of the Kossel now. The reason why we made those X, Y, and Z buttons earlier was to develop 3 representative points that can calibrate each arm effectively. So the way to calibrate an arm is to take a sheet of paper, and we're calibrating the X arm here. I will press the X button on the Kossel. I will press the X button on the Pronterface, and that will send the nozzle to an X location. If it's too close, you'll see the paper cannot be moved underneath the nozzle. In order to calibrate this arm now, you would use an Allen wrench and start turning this set screw. If the nozzle is too close to the bed, turn it clockwise like so. If the nozzle is too far from the bed, you can make it closer by turning this set screw counterclockwise. So once you have this arm calibrated to the right X position and it's passing the paper test, move on to the next arm and calibrate it with the Y position. When you're done with that, make sure to come back to X and ensure that it's still passing the paper test. Similarly, once you do Z, come back to Y, and similarly, once you do X, go back to Z. Make sure they're all passing the paper test simultaneously. As soon as you're done with that, you then want to recalibrate the origin, and you would do that by editing this delta smooth rod offset. The default value will be 221. The reason is because once you've calibrated all of these arms independently, your origin might go off again. So the first thing you would do is go into Pronterface and send the nozzle back to the origin. So you would send it to the origin by clicking this origin button in Pronterface. So now we see that the nozzle has moved away from the heating bed. In order to get it closer, go back into this delta smooth rod offset variable and increase the value. The right way to increase the value is by 0.5 millimeter increments. So I will increase this to 221.5. I will disconnect Pronterface, and then I'll upload the new firmware back to the console. Once the upload is complete, reconnect your Pronterface home the console printer, and click the origin again to send it back. Hi guys, I hope you enjoyed the calibration of the CostalClear printer. Any issues or questions, please feel free to email us at blueeaglelabs@gmail.com or check out our forums, and have a great time.